In this video, we'll generate the binomial series of y equals 1 minus x to the power k. We also generate the trend line and the trend line equation for the polynomial, the expansion coefficient using the Taylor-Maclaurin series sum, and LINEST polynomial regression. Begin with the formula of the binomial series 1 equals 1 minus x to the power k, where our values of k will be from 0 to 6. We'll assign 0 to 6. So we have these values of k, 0, 1, 2, 3, 4, 5, 6. And we generate the trend line, the data set. Array formula. 1 minus x to the power k. And we'll chart this using the scatter chart. And this should be scatter chart. And we generate the trend line equation. So the trend line polynomial raised to the power, we'll put 6 because our k values will be from 0 to 6 and use the equation. And we'll move this downward, relocate this at the bottom for easy comparison with our regression coefficients. So here we have the trend line and the trend line equation. We can change the value to 1. So our polynomial will be y equals 1 minus 1x, which is a straight line. At k equals 2, y equals 1 minus 2x plus x squared. The rest are 0. Next, we generate the Taylor-Maclaurin series sum, where y is also the summation of a times x to the power n, where the value of n is from 0 to infinity. In this case, we can only reach 10, which is still good enough. So we enter the y using series sum. Array formula, series sum of the x values raised to the power n, where n is from 0 to infinity. So starting with 0, incremented by 1. And the coefficient will be this range. Now we can calculate the coefficients. But first we have to make sure that there's an equation here. Our chart will generate the equation, the trend line equation. Trend line to the power polynomial to the power 6. We're almost complete, so we can now complete the coefficient. So array formula, negative 1 to the power n. Then times combina. Combina. So inside the combina will be k minus n. So that's k minus n plus 1, comma n. Enter. So we have an error. This should be 0. So if n exceeds 3, n is 2 here. If it is more than 2, this should be 0. So we have to correct this. So if n is 0 is greater than k, then 0. Now that fix it. So at n equals 4, or k equals 4, so we have our Pascal triangle coefficients here. 1, -4, 6, -4, 1. Next, we calculate this using LINEST, this regression coefficient using LINEST. To do that, we complete the 1 comma x matrix. So this is equal to transpose. And since there's no degree of freedom, so if we have this will be 6, this will be equal to RA formula of the x values raised to the power 0 to 6. And we can enter LINEST of data y, comma, and data x. And this regression coefficient match to our expansion coefficient. LINEST data y and data x. Our regression coefficient match to our expansion coefficient. Now let's go back to the chart. At k equals 0, our polynomial will be y equals 1. At k equals 1, our polynomial will be 1 minus 1x. So 1 minus x. And our coefficient match to our expansion coefficient. At k equals 2, y equals 1 minus 2x plus x squared. The rest are 0. So 1 minus 2x plus x squared. At n equals 3, y equals 1 minus 3x plus 3x squared minus x cubed. And our regression coefficient matches to our expansion coefficient. And k equals 4, y equals 1 minus 4x plus 6x squared minus 4x cubed plus x to the fourth, and the rest are 0. So our regression coefficient matches to our expansion coefficients. At k equals 5, y equals 1 minus 5x plus 10x squared minus 10x cubed plus 5x to the fourth minus x to the fifth, and this is 0. So our regression coefficient is the same as our expansion coefficient. At k equals 6, so we have here y equals 1 minus 6x plus 15x squared minus 20x cubed plus 15x squared minus 6x x to the fifth plus x to the sixth. So our regression coefficient is the same as our expansion coefficient. This completes the binomial series Pascal triangle coefficient of 1 minus x to the power k.